Okay, the Gaussian elimination method refers to a strategy used to obtain the row echelon form of a matrix. The goal is to write matrix A with the number 1 as the entry down the main diagonal and have all zeros below. So if this is the matrix that's given, and then after the Gaussian elimination, we would have zeros below the diagonal where you have a diagonal of all ones. Now the first step of the Gaussian strategy includes obtaining a 1 as the first entry in the upper left hand corner so that row 1 may be used to alter the rows below. So given an augmented matrix, perform row operations to achieve row echelon form. Number 1, the first equation should have a leading coefficient of 1. If not, then interchange rows or multiply by a constant if necessary. Number 2, use row operations to obtain zeros down the first column below the first entry of 1. Number 3, you're going to use row operations to obtain a 1 in the row 2, column 2. And then you're going to use row operations to obtain zeros down column 2 below the entry of 1. Step number 5, you're going to use row operations to obtain a 1 in row 3, column 3. You would continue this process for all rows until there is a 1 in every entry down the main diagonal and there are only zeros below. In step 7, if any rows contain all zeros, then you place them at the bottom. So for example number 3, we want to solve a 2 by 2 system by Gaussian elimination. So the 2 by 2 system is 2x plus 3y equals 6. The second equation is x minus y equals 1/2. So the first thing we want to do is we want to write this as an augmented matrix. So here's the coefficients. The first column represents x, the second column is y. So we have 2, 3, and 6, 1, -1, and 1/2. Now what we want a 1 in row 1, column 1 in the upper left hand corner. Now since there's a 1 in the second row, this can be accomplished by interchanging row 1 and row 2. So we would use the following symbol. We would say this means interchange. So we're interchanging row 1 and row 2. So now row 1 represents 1, -1, 1/2, and now row 2 is 2, 3, and 6. Now in step 3, what we want to do is now that we have a 1 in the upper left hand corner, so if we have a 1 as the first entry in row 1, column 1, we need to get zeros, obtain a 0 in row 2 underneath that 1. So this can be accomplished by multiplying row 1 by -2 and then adding the result to row 2. So this 1, what we can do with that 1 is we want to make this 2 a 0. Well, the opposite of +2 is -2. So what we're going to do is, if you look at this rule here, it's saying we're going to take -2 and multiply it by row 1, meaning -2 times this 1 is -2. And if you add it to the +2, it's going to give you 0. And then we're going to do the same thing with the next number. -2 times row 1, so -2 times -1 is +2. Plus 3 is going to give you 5. -2 times 1/2 is -1. And -1 plus 6 gives you +5. Now, we only have one more step, and that is to get this 5 down here because we want a diagonal of 1 to be 1. Well, all we need to do now in this step is to divide by 5 or multiply it by 1/5 because 5 divided by 5 is going to be 1. So in order to do this, we're going to take 1/5 and multiply it by all the values in row 2. Well, 1/5 times 0 is 0. 1/5 times 5 is 1. And 1/5 times 5 also gives you 1. So now we have a diagonal of 1s and zeros below. And so what this tells us right here is that y, well, technically what this means is we have a 0 for x in row 2, and then we have a y, and that's equal to 1. Now, since this 0 is x, right? It's 0 times x, it doesn't exist. So that means that y is equal to 1. Now, in step number 5, now that we know that y is equal to 1, we can use back substitution, and the second row of the matrix represents y is equal to 1 like we stated, and we're going to back substitute it, y equals 1, into the first equation. Well, the first equation had a coefficient of 1x minus a coefficient for 1y, and that's going to equal 1/2. And then you can see below here, we can then rewrite this equation. So it's going to be x minus 1 equals 1/2. We're going to add 1 to both sides, and we get x, which is equal to 1/2 plus 1, which ends up being 3/2. So now the solution is the point 3/2, 1.